Part 2, Exploring Graphs of Periodic Functions. The sine function. What we're going to do is I've given you a table of values, so from 0 all the way to 360, or one full rotation of the circle, and we're going to graph y equals sine x. Then we're going to connect the points with a smooth curve, okay? So what that means is if x is 0, sine of 0 is 0. If x is 30 degrees, sine of 30 is 0.5. And these are all things that you can check on your calculator. Type in sine of 45, you get approximately 0.707, and so on. Okay? So what we're going to do is we're going to plot those points and then look at the characteristics of the graph. We'll do the same thing for the cosine function. Okay, so let's start. I've already scaled my graph, so if you want to pause the video and do the same on your sheet, feel free to go ahead. Okay, so x is 0, y is 0. So we're going to draw a dot there at the origin. Okay, 30 and 0.5. 45, which is halfway between 30 and 60, because each horizontal or each vertical line is 15 degrees. So that's at about 0.7. Okay, so that's just about here. Okay, 0.866 for 60. So that would be just about here. Okay, and 90 is at 1. Okay, we'll do the same thing coming down the other side. So 120 would be there at 0.866. 135 is at 0.7-ish. Okay, 150, we're at 0.5. At 180, we're crossing the x-axis. Now, if you notice, we start to go into the negatives. So 210 is negative 0.5. Okay, 270 is negative 1. 240 is, let's go 225 is 0.7. And 240, 0.86. Okay, and again down the other side, or up I guess in this case. Okay, and that goes there. 330 is at negative 0.5. And 360 is at 0 again. Okay, so now we can connect our dots with a nice smooth curve to represent all of the angles between 0 and 360. Because I, of course, can go sine of something like 172, okay, and still get a value for it. All right, so what are the x-intercepts? Well, from this graph, we have x-intercepts at 0, 180, and 360 degrees. The y-intercept is also at 0. Now, amplitude. If you notice down below, amplitude is the vertical distance from the midline, which is halfway between the max and the min, to the max and the min. So, here's my maximum, and here's my minimum. Halfway in between is the x-axis. That is my midline. Okay? The amplitude is from the midline to the maximum, or from the midline to the minimum. We don't worry about it being positive or negative. We always describe it as a positive number. Okay? So, if that is 0 and my max is at 1, or my min is at negative 1, then the distance is just 1. The period is the horizontal distance between repetitive points. So, here's where my graph starts, goes up, down, and crosses that midline again here. So this graph has a period of 360 degrees. Okay, again, the midline is the middle. That's a y value, so that's when y is 0. The maximum is at y equals 1. And the minimum is y equals negative 1. The domain, well, remember that this is a function that comes from rotating around the circle. So, if I start here and rotate one full rotation, that's 360. But of course, I can continue to rotate around the circle infinitely number of times. So is there any angle that I can't use? Don't forget, we can also go counterclockwise, so your angles can be negative. Or sorry, go clockwise, so your angles can be negative. So therefore, my domain is x belongs to reals. Okay? Now, my range, because I have a max and a min, then my range has to be between those two things. So -1 less than or equal to y less than or equal to +1. And again, the solid line refers to the fact that y belongs to reals. Okay, so if the period is from starting point to starting point, maximum to maximum, or minimum to minimum, is the period then from x-intercept to x-intercept? Okay, well in this case, that would only be half the period. Because remember, here I'm starting and going upward, whereas when I cross through this x-intercept, I'm going downward. So it has to be the same motion. So again, as I cross this one over here, I'm going upward again. So that would be the same as at the start, and the period is 360. So no, not from x-intercept to x-intercept. Okay, let's take a look at the cosine graph on the next page. Okay, for the cosine function, I did the exact same table. The only difference I made was the fact that I changed the degrees all into radians. So remember we learned previous lesson that if we use pi over 180, we can convert everything into radians. So if I'm referring to 30 degrees, which is where I started the other one, okay, then that would be 30 pi over 180. Divide them both by 30, we get pi over 6, and so on, okay? Again, I have already pre-scaled my graph, so if you want to pause the video to do the same, I'm representing each vertical line by pi over 12, okay? So this is 1 pi over 6, so every 2 spaces is 1 pi over 6, so that makes 2 spaces 2 pi over 6, 3 pi over 6, 4, 5, and so on, all the way up to 12 pi over 6. Now, if you were to simplify 12 pi over 6, that's the same thing as 2 pi, or 1 complete circle. Okay, so do remember, pi over 6 is not reducible, but 2 pi over 6 is the same thing as pi over 3, because 2 and 6 are both divisible by 2. So 2 into 2 once, and 2 into 6 3 times. Okay, all right, super. So I'm going to start plotting the points. Now in this case, when x is 0, we're going to be starting here at 1. Okay, at pi over 6, that's 0.866. At pi over 4, which remember is halfway in between pi over 6 and pi over 3. So pi over 4 would be 0.7. So that's right about there. Okay, and then pi over 3, or 2 pi over 6, is at 0.5. And pi over 2 is the same as 3 pi over 6. That simplifies to 1/2 a pi. Good, and now we go into negatives. So 4 pi over 6. And the 3 pi over 4 is the same as 9 pi over 12, so that would be here. Okay, and 5 pi over 6 is there. And then at 6 pi over 6, or 1 pi, we're here at -1. Do the same on the other side, because it is symmetrical. Okay, and -0.5. And again, 9 pi over 6 is the same thing as 3 pi over 2. We're back to the x-axis. Okay, and we'll proceed back upward into the positives. So that guy would be at 0.5. Okay, and halfway in between, that's my 0.7. 11 pi over 6 would be at 0.866. And 12 pi over 6, or 2 pi, we're back up to the top. Okay, so we can again take that curvy line and connect the dots. Good. Now that looks an awful lot like the sinusoidal or the sine curve, but it's just been moved over a little bit. Okay, so what does that change? Well, that changes our x-intercepts. So if you'll notice, we cross here at 3 pi over 6, or pi over 2, as well as at 9 pi over 6, or 3 pi over 2. My y-intercept occurs at 0, 1. Okay, as you can see here, it crosses the y-axis there. Now, the amplitude, again, is from that max to the midline, or from the min to the midline. Again, that amplitude is just going to be 1. The period for this graph, I have a maximum here at x is 0. I have another maximum at 2 pi, so therefore the period is 2 pi. The midline again is the x-axis, so that's when y equals 0. The maximum is still 1, and the minimum is still negative 1. The domain is x belongs to reals, because again we can continue this graph on in both directions forever and ever. Okay, so then the domain is x belongs to reals, and the range is the same as for cosine. The minimum is negative 1, the max is positive 1. So negative 1 less than or equal to y, less than or equal to 1, y belongs to reals. Okay, so how are the graphs of sine x and cos x similar? Well, they have the same amplitude, the same period. Remember that 2 pi is the same as 360 degrees. They have the same midline, the same max and min, and the same domain and range. So the only thing that's different is their y and x intercepts. Okay? All right. So what change can be made to turn y equals sine x into y equals cos x? Okay, well remember that sine x looks like this. So how do I get this to go here? Well, I have to move it. So I would have to move it left by amount of, remember 3 pi over 6 is the same as pi over 2. So I have to shift this by pi over 2 to the left. Okay, or that's the same as 90 degrees if you're doing this in degrees. Okay, that shift to the left, or we could take the cosine graph and shift it by pi over 2 to the right. That is known as a horizontal translation. Okay, page 494, you get to practice up some of this fun stuff, so I'll leave you to it. Don't forget to show your teacher when you're done.